Suppose an ellipse is positioned in the coordinate plane in such a way that its center is at the origin and the foci are on the x-axis. Suppose that the focus f sub 1 has a coordinate c, 0. Then the focus f sub 2 will have a coordinates negative c, 0 due to the symmetry. Remember that the center is halfway between the foci. Let point P be a point on the ellipse. Let's say point P has coordinates x and y. We want to find an equation in x and y that shows the relation between the coordinates of any point on the ellipse. We'll use for this the equation that defines the ellipse. Distance between the point P and f sub 1 plus distance between point P and f sub 2 is equal to a. Before we'll go to that, let's recall that a was such a positive number that 2a was greater than distance between the foci. And since we are in a coordinate plane now, the distance between foci is 2c. So this tells me that 2a has to be more than 2c, and therefore a is greater than c. So we know that the value of a has to be greater than c, where c, we can say, is the distance between the focus and the center. Any focus will do, the distance is going to be c. So back to the formula. Since we are in a coordinate system, each of those distances can be expressed using the distance formula. And the first distance is going to be square root difference of the first coordinate, so that's going to be x minus c squared, plus the difference of the second coordinate, so it's going to be y minus 0 squared, plus we add distance between point P and f sub 2, which will be x, and in this case we'll have plus c squared plus y minus 0 squared, and this sum is supposed to be 2a. This is the equation of the ellipse. This is the relationship between x and y of any point on the ellipse. However, we can simplify this equation by squaring both sides twice and combining the like terms. You can check the details in the notes or in the textbook. Eventually, after all this algebra is performed, we'll get the equation a squared minus c squared times x squared plus a squared y squared is equal a squared minus c squared. Since a is greater than c, we notice that at the beginning, then a squared is greater than c squared. So we know that a squared minus c squared is going to be positive. And if this is the case, we can define the a squared minus c squared to be b squared. So let b be such the positive number that b squared is equal a squared minus c squared. Since b squared is a squared minus c squared, we can say that b has to be less than a. So we have another relationship between those numbers. And if I replace a squared minus c squared by b squared, then my equation is going to be b squared x squared plus a squared y squared is equal a squared b squared. Dividing every single term by a squared b squared, and reducing each fraction will give me the standard equation of an ellipse, which is x squared over a squared plus y squared over b squared is equal 1. This is the standard equation of the ellipse, with the center at 0, 0 and the foci along the x-axis.